Okay, we're going to make f prime equal to 2 in this problem. So this is equal to 0.1x plus e to the 0.25x. Solving for x, let's say 2 minus 0.1x equals to e to the 0.025x. And the problem, if I natural log both sides, it doesn't really help. If I natural log both sides, sure, this goes away. It's 0.25, 0.025, sorry, 0.25x. Oh, no, that's terrible. It's equal to natural log of 2 minus 0.1x. Now, we're still stuck because we can't get x by itself. So this calculator problem is done a different way. So let me show you guys how. I haven't used Inspire before, but let's see if it works. New graphs. So we're actually going to graph this function. We're going to say y, function y is, we said 0.1x, where's my variable, x minus, sorry, it was minus or plus e to the 0.25x. No, here's x. So leave this one. That's our graph. We want to graph a second graph. Add a graph. Where the f2 is 2. Darn it. How do I mix these together? I've never done this. This is this was free. It actually might still be free. It's an Inspire. So let's add minimum. Let's see if it works even. Oh yeah, it does work. Change this to and 0.1x plus e to the 0.25x. So this point here, so on your graphing calculators, since this is a graphing calculator problem or graphing ability problem, you graph y is equal to 2, and then y is equal to 0.1x e to the 2.5x, and then you find out where they intersect. Let's see how we do that. Sorry, on your graphing calculator, remember we hit calculate intersection point. Let's see. I'll turn it. Let's use add. No, that's not it. Oh, I don't know how to use this, but you guys saw the picture, right? So on your graphing calculator, that's what you have to do. You graph them both separately. Y is equal to 2, then add another graph, 0.1x plus e to the 0.25x, and then find where they intersect. That's it. Symbols, catalog, math operations. Nope. Symbols. Nope. Oops. Okay, I don't know how to use this Inspire, but it was a way for us to graph. Okay. And resume this in case anyone else who hasn't been able to join us. Okay, this is a trig function. And remember, trig functions kind of go up and down, right? This probably keeps going like that forever. And we're asked, between A and B, which of the following points on the graph could be an instantaneous rate of change of f equal to the average rate of change? Ooh. So this is my regular graph, and the average rate of changes, is this graph increasing or decreasing from A to B? So from A to B, that's my boundaries, right? If I draw a line, you can see that this graph is actually decreasing, and this slope is my average rate of change. Okay. Sometimes I'm up, sometimes I'm down, sometimes I'm up again, but overall, this is the average rate of change, accounting for the gains and losses. So that's just the derivative. Now, as I drew that, which of these points, let's see, which of the following points on the graph f could be an instantaneous rate of change of f equal to the average rate of change? Now, are there any points here that would have the same slope? Let's see, if I draw something like that, that looks pretty good. If I draw something in D, let me clean this up a little bit. Try that a little nicer. Okay, that's my average rate of change. If I draw a slope for A, that looks like that. Doesn't look right. If I draw a slope for D, that's going up like this. If I draw a slope for B, darn it, the bed. Yeah. So that's B would be the point that would have the same average rate of change as an instantaneous rate of change. The slope at a point is my instantaneous rate of change. Okay, so here's problem number 5. The graph of f shown above consists of 3 line segments. And you guys can tell it's 3 line segments. Here's our first one. Here's our second one. And then this one is our third one. Right, so it's a piecewise function. Consists of, what is the average rate of change of f from -1, starting at -1, to 6? Okay, average rate of change. So if I draw my slope line, sometimes we go up, sometimes we go down, but the average rate of change is 0. I haven't gone anywhere. So if I think of this like, again, the stock market, I start off at this value, I made money, I've lost money. How much have I made overall from -1 to 6, from -1 to 6? I haven't made nothing. There is no change. If they ask me a question like, what is the average value? Sure, average value, it's sometimes I'm high, sometimes I'm low. The average value would be something probably like there. Average value. So there's 2 different words. There's average rate and average value. And the average rate of change is f of b minus f of a over b minus a. So we can take 0 minus 0 over 6 minus -1. That's still going to be 0. That's our average rate of change. And average value is, we take the integral from a to b of f of x dx, and we divide that over our interval, b minus a. So some people get confused by that. And the average value says, hey, add up all the values here. That's what the integral will do. And we divide that between the intervals of -1 and 6. And it'll be something probably like here. That's the average value, like 3 point something. Okay. And I think that's where people might have been confused about. Okay, number 6. Let x and y be two positive numbers such that x plus 2y equals to 50, and x plus 1 times y plus 2 is a maximum. Okay, just on the side, you don't have to write this, but it might be helpful to some people. Like you can just remind yourself x is greater than 0 and y is also greater than 0 in case you have more than one answer. Then we want to try and maximize this equation on the side. So let's go write it out. X plus 1 times y plus 2 is going to equal to some max value, m. And in order to maximize this value, we're going to take the derivative, and we're going to make m prime equals to 0. Because this graph will be something like increasing and decreasing as x and y changes. So we want to figure out at what value are we going to have a maximum product. Okay, so I'm going to multiply it out to make my life a little easier. You could do product rule if you want right now. You could say the derivative of x is just 1 y plus 2. You could do that, m prime. And then plus the derivative of y is y prime. Wait, if I did this, I would get stuck with two derivatives, which we don't want. We could, like there is a way of doing this where we just go take the derivative of this and then plug in afterwards. But I think us substituting variables is always easier if that's possible first. So let me go ahead and erase this part here. And I'm going to write instead, looking at this here, x plus 2y is equal to 50. Now, we could solve for y. And if I solve for y, this will be 2x equals to 50 minus x, divided by 2, not x, y is equal to 25 minus x over 2, which is fine. If you think solving for x is easier, that's actually also okay. If I write x is equal to 50 minus 2y, both of these ways are okay. So let's do the unconventional one. Let's get rid of x because no fractions. So x now has become, rewriting it, m equals to 50 minus 2y plus 1 and y plus 2. I can combine like terms. That's going to be m is equal to 51 minus 2y and y plus 2. Now, before we could do the product rule, or I'm going to multiply this out. This is actually going to be easier for me. So when I multiply it out, it's going to be a negative 2y squared. That's that. And we'll end up with a negative 4 and a positive 51. They combine out to be a positive 47. Why? Because 51 minus 4 is 47. And we're going to get the last number is going to be plus 102 of my m value. We take the derivative of this because we're looking for m prime. That's the m prime is equal to negative 4y plus 47. Make that equal to 0. Y is equal to 47 over 4. And the negatives make it into a positive. If we know what y is, we need to still find out what the x is. The question was, let x and y be two positive numbers. Oh, they don't have a direction. I guess they're asking me to find out what x and y is. Okay, so let's find out what x and y is. Just to peek at the answer, y is 47. So we got that part right. Let's go ahead and find our x. We have a equation all lined up here, which is kind of useful. So x is equal to 50 minus 2 times 47 over 4. That simplifies to become 50 minus 47 over 2. We can get common denominator. That's 100 over 2 minus 47 over 2 is 53 over 2. That's our x value. Let's answer. Okay, number 8, find all critical points and the point of inflections. No, whoops, wrong one. Number 8 is find A and b so that f of x of that will be a critical point at 2, 3. So again, these are vocabulary words that we need to know. Critical points are f prime is equal to 0, or they don't exist, remember, or they do not exist, like you divide by 0 or something. Okay. So to get there, we're going to go and just do the f prime of x is equal to x cubed plus, darn it, I'll just writing it, 3x squared plus a is a constant, so we can leave it alone. So it's 2ax plus b is a constant, so that goes away. 3, 2, 2, 1, yeah. And our goal is to make this equal to the slope. Oh, we'll have a critical point at 2, 3. So we want x and y, or x to be 2. I don't know why I wrote that, but x is 2. So we just plug it in. If x is 2, that's 3 times 2 squared is 4. And 2 times 2 is 4. No, yeah, 2 times 4a equals to 0. That's 12. Move it over. 4a is equal to negative 12. Then a has to be negative 3. And if we know a is negative 3, what does our b value have to be? Let's go ahead and plug it back in. We know f of x, well, specifically f of 2 is 3. So 3 is equal to 2 cubed. We can write this x cubed plus, no, sorry, not plus, it's a minus now, because we found that a was a negative 3. X squared plus b. We know what x is, plugging in x, minus 3, 2 squared plus b. That's 3 equals to 8 minus 12 plus b. Need some space. 3 is equal to negative 4 plus b. B is equal to 7. Yep, that's our answer. So make sure you point out that b is 7 and a is negative 3.